The universe hides a terrifying face behind its veil of stars. We are about to journey into the cosmos's darkest side, unveiling 25 space horrors that will transform how you see the void. You will discover the unseen forces actively shaping our fate and the existential threats lurking in the darkness. What cosmic mystery could erase reality itself in an instant? And why does the profound silence of space suggest we might be doomed? Which of these cosmic terrors do you think poses the greatest threat to our future? A silent, irresistible force is dragging our entire galaxy towards an unknown fate. This is the Great Attractor, a gravitational anomaly of such immense power that it pulls not just the Milky Way, but hundreds of thousands of other galaxies in a relentless cosmic flow. Picture a vast, unseen river in space, with entire islands of stars all floating in the same direction, caught in a current we cannot see. The source of this pull lies in the direction of the Norma cluster, approximately 250 million light-years away. But its true heart is hidden from our view, shrouded behind the dust and stars of our own galaxy's central bulge in a region astronomers call the zone of avoidance. It is a place we simply cannot peer into with traditional telescopes, making the Great Attractor one of cosmology's most profound puzzles. What could possibly possess enough gravitational might to command the motion of galaxies themselves? The force required is almost unimaginable, equivalent to the pull of tens of thousands of Milky Ways all concentrated into one point. For decades, its nature was pure speculation. Was it a massive, concentrated over-density of matter, a cosmic structure so vast it defied explanation? Or was it something even stranger? This mystery forced us to look deeper, leading to an even more startling discovery about what lies beyond this great pull. While we are pulled toward one great mystery, an even more solitary terror drifts in the void between galaxies. These are rogue black holes, the ultimate cosmic phantoms. They are the remnants of chaotic galactic collisions or the explosive recoil from merging supermassive black holes, flung from their home galaxies to wander the darkness alone. A rogue black hole carries the mass of a star or even millions of suns, compressed into a point of infinite density, completely invisible against the blackness of space. It gives off no light, no radiation to betray its position. Its presence is only revealed by the way it warps the very fabric of reality around it, a gravitational lens bending the light from distant stars. Imagine such an object with the mass of our own sun, drifting silently into the outer reaches of our solar system. We would not see it coming. The first sign would be subtle, a slight wobble in the orbits of the outer planets. Then the Kuiper belt of icy bodies would be stirred into chaos, comets and dwarf planets flung in all directions. As it drew closer, its immense gravity would begin to pull at the entire solar system. Planetary orbits would distort, stretching into strange, elliptical paths. The delicate balance that has held our world stable for billions of years would be utterly undone. Earth could be pulled from its life-giving orbit, either flung into the deep freeze of interstellar space or dragged inward toward a fiery end. The rogue black hole would not even need to consume a planet directly. Its gravitational influence alone would be enough to sterilize our solar system, leaving a trail of celestial wreckage in its wake as it continued its endless, silent journey. The silent drift of a rogue black hole is a tangible terror, but an even more profound threat could rewrite reality itself without any warning. This is vacuum decay, a concept from quantum field theory that suggests the very ground state of our universe might be unstable. Think of the universe not as empty space, but as a field of energy like a vast, calm ocean. This ocean, specifically what physicists call the Higgs field, is what gives particles their mass and makes our reality possible. But what if this calm ocean is not in its deepest, most stable valley, but is merely trapped on a high plateau? This precarious state is known as a false vacuum. At any moment, a random quantum event could create a tiny bubble of true vacuum, a spot where the field drops to its absolute lowest, most stable energy state. This bubble would then expand in all directions at the speed of light. The laws of physics inside this bubble would be completely different. The fundamental constants that govern forces like gravity and electromagnetism would change instantly. Atoms could not hold together, molecules would disintegrate. Every structure in the universe, from a single hydrogen atom to the largest galaxy cluster, would cease to exist in any recognizable form. The universe would be erased and rewritten with a new, alien set of rules. There would be no explosion, no sound, no light. Just an invisible wall of dissolution moving at the ultimate speed limit, making it utterly impossible to see coming. One moment, reality as we know it exists. The next, it is gone forever. While the probability of this happening in any given year is infinitesimally small, the sheer finality of such an event leads some physicists to consider it the most ultimate and absolute end of everything scenario imaginable. The unsettling possibility of our reality being instantly rewritten makes the profound silence of the cosmos even more chilling. This silence is the heart of the Fermi Paradox, a simple question with terrifying implications. If the universe is so vast and old, teeming with billions of planets that could support life, then where is everybody? The cosmos should be buzzing with the transmissions and megastructures of countless civilizations, yet we hear nothing but a deafening quiet. One potential answer to this paradox is the concept of a great filter. This is the idea that there exists some kind of catastrophic barrier, a nearly impossible challenge that prevents life from advancing to the point of becoming a visible, spacefaring civilization. This filter could be a single, universal event or a series of them that almost every intelligent species encounters and fails to overcome. The existential dread comes from not knowing where this filter is located in the grand timeline of a civilization's development. Is it safely behind us, something we have already miraculously survived? Perhaps the spontaneous origin of life itself was the filter, a fluke of chemistry so rare that we are truly alone. Or maybe the jump from simple prokaryotic cells to complex eukaryotic life was the cosmic bottleneck, an event that took billions of years on Earth and might be extraordinarily uncommon across the galaxy. If the filter is behind us, we are the first, the lonely pioneers in a dead universe. The far more terrifying prospect is that the great filter still lies ahead of us. It could be a technology we have not yet invented but inevitably will, something that proves to be our self-destruction. The discovery of advanced artificial intelligence that turns against its creators, the manipulation of genetic code that leads to a planet-wide plague, or the creation of a physics experiment that accidentally unravels space-time itself. Every new technology we develop could be the one that triggers our own filter, the final step that every other civilization has taken before vanishing into silence. This adds a horrifying layer to our search for alien life. If we were to find simple bacterial life on Mars or Europa, it would be a momentous discovery, but it would also suggest that the first steps of life are common. This would mean the great filter is not behind us, increasing the probability that our doom still awaits. And if we were ever to find the ruins of an ancient alien civilization, the evidence of a species that reached the stars and then disappeared, it would be the most frightening discovery in human history. It would confirm that the filter is real and that it is waiting for us just ahead. The silence of a dead cosmos is terrifying enough, but a sudden, brilliant flash could be infinitely worse. Gamma-ray bursts are the universe's most powerful explosions. Catastrophic events that release more energy in a few seconds than our sun will emit in its entire 10 billion-year lifetime. These are not the slow, creeping threats of a rogue black hole or vacuum decay, but sudden, violent detonations signaling the death of a massive star or the collision of ultra-dense neutron stars. For a brief moment, such a burst outshines every other source of gamma rays in the entire cosmos. The danger lies in the beam. These explosions do not radiate energy evenly in all directions, but instead focus it into two narrow, opposing jets of intense radiation that scream across the universe. If one of these jets were to be pointed directly at our solar system from even a moderately nearby distance, the consequences would be apocalyptic. The initial flash of gamma rays would be invisible to our eyes, but it would slam into our atmosphere with the force of a nuclear bomb detonating over every square inch of the planet. This high-energy radiation would break apart the molecules in our upper atmosphere, chemically transforming it and devastating the planet's ozone layer. This protective shield, which guards all life from the sun's deadly ultraviolet rays, would be stripped away in a matter of minutes. The sky would then become a source of death. The sun, our source of life, would begin to bake the planet's surface with a sterilizing intensity. Ecosystems would collapse from the bottom up as phytoplankton in the oceans and plants on land die off, breaking the food chain. Widespread extinctions would follow, a global biological catastrophe on a scale not seen for hundreds of millions of years. We are not completely defenseless, as these events are rare in our galactic neighborhood. But the universe is a violent place, and a gamma-ray burst is a stark reminder that our existence here is contingent on being far away from the wrong place at the wrong time, and lucky enough to be outside the lethal cone of a cosmic lighthouse that could erase us in the blink of an eye. A gamma-ray burst from the depths of space is an external threat, but a catastrophe of our own making is silently taking shape just overhead. The Kessler syndrome is a chain reaction of destruction waiting to be unleashed in Earth's orbit. Picture the space around our planet not as a pristine void, but as a busy highway crowded with active satellites, derelict rocket bodies, and countless fragments of past missions. This orbital junkyard is the tinder for a fire that could burn for centuries. The nightmare begins with a single, random impact. A defunct satellite collides with an old rocket stage. They are not merely dented, they are utterly obliterated, transforming two large objects into a swirling cloud of tens of thousands of jagged fragments, each one traveling at over 17,000 miles per hour. At such velocities, even a fleck of paint carries the destructive energy of a hand grenade. This initial cloud is only the first domino to fall. Each new piece of shrapnel becomes a hypervelocity projectile, vastly increasing the probability of striking other objects in orbit. One collision leads to 2, then 4, then 8. The cascade accelerates exponentially, a runaway chain reaction where every impact creates more debris, which in turn makes more impacts inevitable. Within a matter of days or weeks, a critical density is reached and the chain reaction becomes self-sustaining. The region of space around Earth transforms into an impassable shrapnel field. This is the Kessler syndrome in its full, terrifying glory. The immediate consequences would be the silent, systematic destruction of our orbital infrastructure. Communication satellites that carry global data, GPS networks that guide everything from phones to ships, weather monitoring stations that warn us of hurricanes, and telescopes that peer into the cosmos would all be pummeled into Swiss cheese. One by one, they would go dark, plunging our technologically dependent civilization back decades in an instant. But the true, long-term horror is what comes next. Launching anything through this orbital minefield would become a suicidal gamble. Any new satellite or rocket would be torn apart within hours or days. The International Space Station would be evacuated, its crew returning to an Earth now permanently isolated. The space age would effectively end. We would be trapped on our own planet, looking up at a sky we could no longer reach, surrounded by a shimmering, metallic prison of our own creation. The window to the stars would be slammed shut, perhaps for centuries, until the slow drag of the upper atmosphere finally cleansed the deadly debris. This is not a far-fetched science fiction plot. With thousands of new satellites being launched by private companies, the orbital environment is more crowded than ever before. The Kessler syndrome is a ticking clock, a reminder that our greatest achievements in space could ultimately forge the chains that bind us to Earth forever. This orbital prison of our own making is a local terror, but the cosmos holds voids of emptiness so vast they defy comprehension. The Boötes void is one such place, a spherical region of space so profoundly empty it has been called the Great Nothing. Stretching for 330 million light-years across, it is a cavern in the fabric of the universe, a place where galaxies simply refuse to form. If you were to place our Milky Way at its center, we would be one of only a handful of islands in an ocean of absolute blackness. The expected number of galaxies in a region this size is in the tens of thousands, yet astronomers have found only 60. The sheer scale of this emptiness is difficult to grasp. Light itself takes millions of years to traverse this void, a journey through near total nothingness. What could possibly cause such a staggering absence of matter? One theory points to the large-scale structure of the universe, which resembles a cosmic web of filaments and nodes. The Boötes void could simply be the space inside one of the largest bubbles in that web, a natural consequence of the uneven distribution of matter following the Big Bang. Yet its size pushes the limits of what our current models of cosmology can comfortably explain. This has led to more speculative and far more chilling possibilities. Could such a void be artificial? Some have proposed the terrifying notion that it is evidence of a Type 3 civilization on the Kardashev scale, a culture so advanced it can harness the power of entire galaxies. Such a civilization might not build starships, but instead slowly dismantle entire galaxies over eons, harvesting every last bit of their matter and energy for purposes we cannot even conceive. The Boötes void would then be the ghost of a galactic graveyard, a territory stripped clean. While this is an extreme hypothesis with little evidence, the void's existence forces us to confront a profound and eerie loneliness. Is the universe not just silent, but in some places deliberately emptied? The Great Nothing stands as a monument to the cosmos's capacity for pure, unsettling emptiness, a hollow in reality that echoes with unanswerable questions. The profound emptiness of cosmic voids is unsettling, yet the stellar graveyards of our own galaxy hide a violence that defies the finality of death. Certain stars refuse to die peacefully, instead rising from their own ashes in catastrophic rebirth. These are the zombie stars, and their existence shatters our fundamental understanding of stellar life cycles. The most common of these cosmic revenants is born from a white dwarf, the dense, Earth-sized core of a sun-like star that has exhausted its nuclear fuel. This stellar corpse should simply cool and fade over eons into a black cinder. But if this white dwarf has a close stellar companion, a binary partner, it can begin a gruesome process of cosmic cannibalism. Using its immense gravity, the white dwarf slowly strips material, primarily hydrogen, from its companion star. This stolen gas accumulates on the white dwarf's surface, building up pressure and heat over thousands of years in a process called accretion. The dead star begins to feed. With each passing millennium, the stolen atmosphere grows denser and hotter. Eventually, the pressure at the base of this hydrogen layer becomes so extreme that it triggers runaway nuclear fusion. This ignition is not a gentle process. It is a titanic thermonuclear detonation that rips across the white dwarf's surface in a violent flash. Astronomers call this a nova, a stellar outburst that can make a faint star visible to the naked eye for a brief, brilliant period. But this is merely a precursor to the true cataclysm. If the accretion continues, if the white dwarf keeps feeding, its total mass begins to approach a critical, universal limit known as the Chandrasekhar limit. As it nears this threshold, the entire star, now a colossal bomb of carbon and oxygen, becomes unstable. The core temperature skyrockets, and in an instant, carbon fusion ignites uncontrollably throughout the entire white dwarf. There is no force in the universe that can contain it. The star tears itself completely apart in a Type Ia supernova, an explosion so brilliant and standardized that it can outshine an entire galaxy. For a few weeks, this single detonating corpse releases more light than billions of normal stars combined. This was always thought to be the definitive, absolute end. The white dwarf was believed to be utterly annihilated, leaving behind no central remnant, only an expanding cloud of glowing debris. Recent discoveries, however, have unveiled a horror that should not be. Astronomers have observed supernova remnants where, against all odds, the white dwarf appears to have survived. It is still there, a shattered, scarred, but active object lurking in the wake of its own supposed destruction. Even more baffling are the cases of stars that have seemingly endured multiple supernova explosions. How is this possible? How can a star explode in a blast designed to vaporize it completely, only to remain and potentially do it again? One terrifying theory suggests these zombie stars might only partially detonate, their explosions failing to consume the entire core. A portion of the white dwarf could survive the blast, wounded but still active, ready to resume its vampiric feeding from its companion. It would begin the cycle anew, gathering fuel for another eventual, but perhaps incomplete eruption. This defies the very laws of physics as we understand them. It means that stellar death is not a single event, but a cycle of resurrection and destruction. These cosmic zombies challenge our most basic textbooks, forcing us to ask what other violent secrets the graveyards of stars might hold. Zombie stars shatter our understanding of death, but an even more pervasive mystery holds the entire cosmos in an invisible cage. Dark matter is the unseen architect of the universe, a ghostly substance that makes up over 80% of all matter. We cannot see it, touch it, or detect it with any of our instruments, yet its gravitational pull is the master force sculpting the largest structures in existence. We only know it is there because of what it does to the things we can see. Stars on the outer edges of spiral galaxies, like our own Milky Way, orbit at speeds that defy the laws of gravity. Based on the visible mass of stars and gas, these stars should be flung out into the void. Something with immense gravity, something we cannot see, is holding them in place. This invisible halo of dark matter acts as a cosmic glue, preventing galaxies from flying apart. The same force shapes the behavior of entire galaxy clusters, bending the light from more distant objects in a phenomenon known as gravitational lensing. The sheer amount of this stuff is staggering. For every single particle of normal matter that makes up our bodies, our planet, and every star we see, there is 5 times more dark matter flowing right through us. We are swimming in an ocean of ghosts, oblivious to the tide. This leads to a deeply unsettling possibility: the existence of dark galaxies. Vast, cohesive structures of pure dark matter could be drifting silently through space, lacking the regular matter needed to ignite stars and become visible. Our own Milky Way could be surrounded by these phantom satellites, invisible neighbors whose only presence is a faint gravitational whisper. We are living in a universe dominated by a substance we cannot perceive, a form of matter that fundamentally does not interact with the world of light and atoms that defines our reality. It is the ultimate cosmic censorship, a reminder that most of the universe is not just unknown, but perhaps forever unknowable. Dark matter is the universe's invisible cage, but some cosmic structures are terrifyingly visible and defy all natural explanation. The Red Rectangle Nebula is one such object, a celestial geometry so perfect it feels artificial. Located about 2,300 light-years away, this nebula does not look like the typical, chaotic clouds of gas and dust we are used to seeing. Instead, it presents itself as a series of startlingly precise concentric rectangles, appearing like a giant crimson X in space or an immense glowing spiderweb. Its symmetry is so unnerving that it immediately sparks a single, haunting question. How can the random, violent processes of stellar death produce something that looks so deliberately designed? The answer lies in a complex and beautiful dance of death between two stars. At the heart of the red rectangle lies a close binary system, two stars locked in a tight orbital embrace. One of these stars is in its final death throes, having exhausted its nuclear fuel and now shedding its outer layers into space. This expelled material does not fly off in all directions, however. The gravity and orbital motion of the companion star act like a cosmic paddle, shaping the outflow of gas and dust into two powerful, opposing cones. Because we are viewing this double cone system almost perfectly edge-on, the rims of the cones appear to form the distinct X shape. The stunning ladder-like rungs, the lines that make it look like a set of glowing stairs, are believed to be the result of periodic puffs of material ejected from the system at regular intervals. As the stars orbit, they release these expanding shells of gas, and when new ejector rams into the older, slower-moving material, it creates shock waves that light up, tracing the edges of the cones and producing the nebula's bizarre rectangular rings. While the physics provides a logical explanation, the visual effect remains deeply unsettling. Our brains are wired to recognize patterns, and such a stark, geometric shape in the randomness of space triggers a primal sense of the unnatural. It is a cosmic mimic, a structure that looks like the work of intelligence, yet is born from pure, mindless mechanics. This nebula is a ghostly cathedral built by stellar winds and gravity, a reminder that the universe can create forms of chilling precision without any guiding hand at all. The universe can construct ghostly geometries without a mind, but it was a burst of pure information that delivered one of history's most profound chills. On a quiet Ohio night in August 1977, a volunteer for the SETI Institute named Jerry Amon was reviewing data from the Big Ear radio telescope. The system was methodically scanning the sky, listening for any signal that stood out from the cosmic background noise. As his eyes scanned the long printout, he saw a column of alphanumeric code representing signal intensity. Most entries were a jumble of letters and numbers, the expected static of the universe. Then he saw it, a sequence of characters so startling, so perfectly aligned with what an artificial signal would look like, that he circled it in red pen and wrote a single, breathless word in the margin. Wow! The wow signal, as it became known, was a 72-second burst of intense, narrowband radio waves. It came from the direction of the constellation Sagittarius, and it matched the exact frequency that scientists had predicted an alien civilization might use, the hydrogen line, a quiet channel in the radio spectrum. For those 72 seconds, it was the loudest thing in the sky, then it vanished, never to be heard again. The signal's characteristics were what made it so compelling. It was not the broad, messy emission of a natural cosmic event. It was a clean, focused radio scream, the kind of signal a transmitter makes. The fact that it appeared and then disappeared as the telescope's fixed beam moved across the sky was exactly what astronomers would expect from a distant, pinpoint source. The search for a repeat began immediately and has continued for decades, scanning the same patch of sky with ever more sensitive equipment. The silence has been absolute. That singular, unrepeated event is the core of its terror. If it was a message, we heard only one word. If it was a beacon, we passed through its beam for barely a moment. The most plausible natural explanations all seem to fall short. Could it have been a signal reflected off a piece of space debris? Nothing in orbit matches the profile. Was it a comet? No known comets were in that region of space at the time. The possibility that it was a human transmission, perhaps a secret military signal, has also been largely ruled out, as such broadcasts are prohibited on that protected frequency. We are left with a ghost in the machine, a one-time event that perfectly fit the profile of an extraterrestrial hello. The wow signal embodies the ultimate cosmic tease, a fleeting whisper that suggests we are not alone, while the enduring silence that followed screams that we might be eternally isolated. It is a single data point of profound possibility, a crack in the door of reality that opened for just 72 seconds before slamming shut forever, leaving us to wonder if we truly heard something, or if the universe was simply playing a cruel and random trick. That fleeting signal from the void speaks of isolation, but our own galaxy is a predator in a crowded sea. Galactic cannibalism is the brutal reality of cosmic evolution, a process where larger galaxies violently consume their smaller neighbors, tearing them apart over billions of years. Our own Milky Way is not a serene island of stars, but a dynamic and predatory structure actively feeding on smaller galaxies right now. The Canis Major Dwarf Galaxy is our current victim, a tiny satellite galaxy that has come too close. The Milky Way's vastly superior gravitational pull is systematically shredding it, stretching the dwarf galaxy into a long, stellar stream that wraps around our own galactic core. This stream is a river of stars, the dismembered remains of a galaxy being digested by a larger beast. This is not a rare event. Throughout the cosmos, large spiral galaxies grow by consuming smaller ones, their gravitational tides acting as cosmic jaws that pull and tear until the smaller structure loses all coherence, its stars assimilated into the larger whole. The ultimate expression of this violence lies in our future. The Andromeda Galaxy, our closest large neighbor, is on a collision course with the Milky Way. The two spirals are hurtling towards each other at a speed of over 250,000 miles per hour. In approximately 4.5 billion years, they will meet. The initial collision will not be a fiery explosion of stars crashing, for the voids between stars are so vast that direct impacts are unlikely. Instead, it will be a gravitational cataclysm. The two galaxies will pass through each other, their mutual gravity warping and distorting their beautiful spiral arms beyond recognition. Stars will be flung out on long, chaotic trajectories into the intergalactic darkness. Giant tidal tails of gas and dust will be ripped away, glowing with the light of newly ignited stars. Over the course of billions of years, the two galaxies will slow, fall back, and merge completely, their dance of destruction culminating in a single, enormous elliptical galaxy, a bloated remnant of a cosmic feast. This future merger underscores a terrifying truth. The universe is in a constant state of violent rearrangement, and the serene night sky we see today is merely a snapshot in a billion-year war for survival. Beyond the predatory dance of galaxies lies a frozen, silent reservoir of ancient ice. The Oort cloud is a vast, spherical shell of icy debris believed to encase our entire solar system like a distant gossamer cage. It stretches nearly a light year into the void, a region so far away that the sun is just a particularly bright star in its perpetual twilight. Here, countless trillions of cometary nuclei drift in a deep freeze, pristine remnants from the solar system's violent birth over 4.5 billion years ago. Each one is a dirty snowball of ice, rock, and frozen gases, a potential comet waiting for a push. That push can come from the gentlest of cosmic whispers. A star passing many light years away, its gravity a faint but persistent tug, can nudge one of these icy worlds from its stable orbit. The tidal forces of the Milky Way itself, the gentle pull of the galaxy's overall gravitational field, can also stir this cloud of sleeping giants. When disturbed, these objects begin a slow, million-year fall inward, accelerating as the sun's gravity takes hold. They become long-period comets, celestial strangers on elongated, elliptical orbits that bring them screaming into the warmth of the inner solar system. This is the true peril of the Oort cloud, its unpredictable nature. Unlike the asteroids of the inner belt whose orbits we can map and predict, these comets arrive from any direction with little to no warning. They are cosmic ambushers, their long, dark journeys offering us no chance to see them coming until they are already upon us. When one does enter the inner system, the sun's heat transforms it. Frozen gases vaporize, erupting from the nucleus to form a magnificent, glowing coma and a spectacular tail that can stretch for millions of miles. We see this as a beautiful celestial visitor, but its beauty belies a terrible potential. The core of a long-period comet can be dozens of miles across, a mountain of ice and rock traveling at immense speeds. An impact with Earth would release energy dwarfing all our nuclear arsenals combined. It would not be a local event, but a global extinction trigger capable of erasing civilizations just as one likely did for the dinosaurs 66 million years ago. The Oort cloud is a constant reminder that our planet's safety is an illusion, maintained only by the sheer, empty volume of space and the fragile luck that keeps those frozen sentinels at bay. Our own world has avoided the deep freeze of the Oort cloud, but a different kind of hell awaits any planet that strays too far from climatic balance. Venus presents the solar system's most terrifying example of a world gone wrong, a permanent cautionary tale written in scorching acid and crushing pressure. Today, its surface is a true inferno, with temperatures consistently around 870 degrees Fahrenheit, hot enough to melt lead and incinerate any organic material instantly. The atmospheric pressure is 92 times greater than Earth's, equivalent to the crushing weight found nearly 3,000 feet beneath our ocean waves. Yet, scientists believe that in its distant past, Venus may have been strikingly similar to early Earth, possibly even sporting shallow oceans of liquid water. So what catastrophic event transformed a potential paradise into a planetary pressure cooker? The answer lies in a runaway greenhouse effect. This is a climate feedback loop with no off switch. Imagine a planet receiving just a little too much solar energy. Its oceans begin to warm and more water evaporates into the atmosphere. Water vapor is itself a potent greenhouse gas, so it traps more heat, which in turn causes even more evaporation. The cycle accelerates, pushing the planet past a point of no return. On Venus, this process likely went into overdrive. As water vapor filled the atmosphere, ultraviolet radiation from the sun began to break it apart. The lightweight hydrogen atoms escaped into space forever, while the oxygen combined with other elements. The planet was literally boiling its oceans away into the cosmic void. With the oceans gone, the primary mechanism for drawing carbon dioxide out of the atmosphere vanished. Any carbon locked in rocks was eventually baked out by the rising heat, flooding the atmosphere with immense concentrations of CO2. This dense blanket of gas trapped solar energy with ruthless efficiency, creating the permanent, searing oven we observe today. The terrifying parallel to our own world is impossible to ignore. While Earth's situation is vastly different, we are conducting a planetary-scale experiment by rapidly releasing billions of tons of greenhouse gases into our own atmosphere. We are not headed for a Venus-like state anytime soon, but the fundamental physics is the same. We are thickening the atmospheric blanket that keeps our planet warm. The concern is not that Earth will become another Venus, but that we risk triggering our own, slower-moving version of irreversible climate tipping points. Melting permafrost releases methane, another powerful greenhouse gas. The loss of polar ice reduces the Earth's ability to reflect sunlight, absorbing more heat instead. These are the same types of self-reinforcing feedback loops that sealed Venus's fate. Our sister planet stands as a stark monument to the delicate balance required for a world to remain alive, a permanent reminder that a planet's climate can be pushed from habitable to hellish, and that some doors, once opened, may never close again. The silent, scorching fate of Venus is a slow-burning apocalypse, but the cosmos also delivers death with metronomic precision. Pulsars are the universe's ultimate timekeepers, born from the most violent deaths imaginable. When a massive star goes supernova, its core can collapse into a rapidly spinning neutron star, a city-sized object so dense that a single teaspoon of its material would weigh billions of tons. This stellar corpse possesses a magnetic field trillions of times stronger than Earth's, focusing its decaying energy into two narrow, powerful beams of radiation that shoot out from its magnetic poles. If these poles are misaligned with the star's axis of rotation, the beams sweep through space like a cosmic lighthouse. From our distant vantage point, we see this as a rapid, perfectly timed pulse of radio waves, X-rays, or gamma rays with a regularity that rivals atomic clocks. The first pulsar discovered, known as CP1919, had a period of just 1.337 seconds, its signal so unnervingly perfect that astronomers briefly nicknamed it LGM-1 for little green men pondering if they had found an alien beacon. The reality is far more terrifying than any artificial signal. A pulsar is not merely a dead star, it is a furious engine of annihilation. Its beams are not just light, they are a torrent of high-energy particles and radiation capable of sterilizing entire star systems. Imagine a world orbiting a pulsar, bathed in the rhythmic flash of these lethal beams. Each pass would deliver a wave of radiation equivalent to detonating our entire global nuclear arsenal over every square inch of the planet's surface. The atmosphere would be ionized and stripped away, the surface scoured clean of any complex molecules, leaving a barren, irradiated rock. Even from a greater distance, a pulsar's relentless particle wind, a continuous outflow of energetic matter from its surface, would act like a cosmic sandblaster, eroding planetary atmospheres over millions of years and leaving behind dead worlds. These lighthouses do not guide ships to safety, they mark the graves of solar systems, their unwavering ticks counting down the seconds until any nearby life is utterly extinguished. The universe's precise timekeepers mark a violent end for solar systems, but a far more final and all-encompassing doom governs the fate of everything. Dark energy is the most dominant and most mysterious force in the cosmos, an anti-gravitational pressure that is causing the very fabric of space to expand at an ever-increasing rate. This discovery, which earned a Nobel Prize, was one of the most shocking in modern cosmology. By observing distant supernova, astronomers found that the universe is not just expanding as we have known for a century, but that this expansion is accelerating. It is as if you tossed a ball into the air, only to watch it fly upward faster and faster, defying gravity itself. Something is actively pushing the cosmos apart, and we call that something dark energy. The implications are as profound as they are chilling. For billions of years, the gravitational attraction of matter, both dark and normal, fought a cosmic tug of war against this repulsive force. In our local universe, gravity won, allowing galaxies and clusters to form. But around 5 billion years ago, a tipping point was reached. As the universe expanded and became more diffuse, the density of matter dropped, while the strength of dark energy, which seems to be an intrinsic property of space itself, remained constant or even grew stronger. Dark energy began to win the war. Now it dominates the cosmos, and its victory is absolute. This leads to a terrifying ultimate scenario known as the Big Rip. If the repulsive force of dark energy continues to strengthen over trillions of years, its push will eventually overcome every force that holds things together. The end would not come with a bang or a crunch, but with a silent, inexorable tearing apart of reality itself. First, the cosmic scales would fail. The gravitational glue holding galaxy clusters together would be overpowered. Galaxies would be flung away from each other, disappearing over a horizon of expanding space, leaving our Milky Way utterly alone in a vast, darkening void. But the horror would not stop there. As the acceleration intensifies, dark energy's push would overcome the gravity binding our own galaxy. Stars would be ripped from their orbits, sent flying into the emptiness. Then it would target our solar system. The sun's gravity would no longer be enough to hold the planets. Earth would be flung away from its life-giving star, a frozen rock on a lonely trajectory into nothingness. The destruction would then become personal. The force would grow stronger than the electromagnetic bonds holding our planet together. Earth itself would be torn asunder, mountains, rocks, and dust pulled apart in a final, catastrophic rupture. And in the last fleeting moments before the very concept of time loses all meaning, the force would exceed the nuclear strong force that binds atomic nuclei together. Every molecule, every atom, every proton and neutron in what was once you, me, and everything we ever knew would be violently shredded into a diffuse, non-interacting mist of fundamental particles separated by distances that become infinite. The universe would not end in fire or ice, but in a state of absolute, irreversible isolation where nothing could ever interact with anything else again. While this ultimate end is trillions of years in the future, the mere fact that the physics of our universe allows for such a scenario forces us to confront a sobering truth, that the vacuum of space is not empty, but filled with a latent, destructive power that is, moment by moment, determining our final fate. The sun's steady light is a comforting lie. Our star is a seething ball of plasma, capable of sudden, violent outbursts that could unravel the very fabric of our modern world. These are solar superstorms, and their most terrifying weapon is the coronal mass ejection. Imagine the sun hurling a billion-ton cloud of magnetized plasma directly at Earth, traveling at millions of miles per hour. This is not mere radiation, it is a physical assault, a solar tsunami crashing into our planet's protective magnetic field. The last time we experienced a direct hit from a true monster was in 1859. Telegraph operators were the high-tech workforce of their day, and on the 1st of September they witnessed something impossible. Telegraph systems across Europe and North America suddenly failed. Paper strips in their machines burst into flames from induced electrical currents. Operators received severe shocks from their equipment. Some even found they could unplug their batteries and still send messages, powered solely by the celestial fury raining down from the sky. Auroras, normally confined to the polar regions, were seen as far south as Cuba and Hawaii, so brilliant that people could read newspapers by their light in the middle of the night. This was the Carrington event, named for the astronomer who observed the colossal solar flare that preceded it. For the mid-19th century, it was a spectacular light show and a curiosity that broke a few telegraph lines. For our 21st century world, an identical storm would be an extinction-level event for our technology. A coronal mass ejection of that magnitude today would slam into our planet's magnetosphere, shaking it like a bell. The resulting geomagnetic storm would induce colossal electrical currents in anything long and metallic, most catastrophically in our continental power grids. Massive transformers, the heart of our electrical infrastructure, would be overloaded and fried, burning out in a cascade of failures. Unlike a local blackout where power can be rerouted, this would be a continental-scale burnout. The lights would go out and they would not come back on. Not for weeks, not for months, perhaps for years. The time required to manufacture and replace these city-sized transformers, which are built to order and not kept in warehouses, could stretch into a decade. This is where the horror truly begins. With the grid down, the dominoes fall with terrifying speed. Water treatment and distribution systems fail, cutting off the clean water supply within days. Perishable food and medicine spoil as refrigeration vanishes. Fuel pumps at gas stations stop working, halting nearly all transportation. Banking and financial systems collapse, erasing digital wealth and crippling commerce. Hospital backup generators would run for a short time, but without a functioning supply chain for fuel and parts, even they would fall silent. Communication networks from the internet to cell phones would be obliterated, severing our digital nervous system and plunging us into an informational dark age. We would be thrown back to a pre-industrial existence, but with one horrifying difference. We would have 8 billion people on a planet whose support systems are entirely dependent on the electricity that just vanished. The social fabric would tear under the strain of such a catastrophic loss. The Carrington event was a warning shot, a solar flare that missed the technological bullseye by a century. A direct hit from a storm of that magnitude is not a matter of if, but when. our sun remains a sleeping giant, and its next temper tantrum could send us back to the dark ages overnight. While our sun threatens to plunge our world into darkness, another world in our solar system already exists in a permanent deep freeze, harboring a biology that would be utterly alien to us. Saturn's largest moon, Titan, is a haunting mirror of Earth, but one warped by extreme cold. It is the only other body in our solar system with stable liquid on its surface, yet these are not lakes of water. They are vast, placid pools of liquid methane and ethane, resting at a surface temperature of -290 degrees Fahrenheit. This creates a landscape that is both eerily familiar and profoundly strange. Imagine standing on the shore of a Titanian lake, looking out at a dark, oily sea under a thick, orange haze. Volcanoes that spew water and ammonia instead of lava might dot the horizon. Methane rain falls from the sky, carving river channels and feeding the lakes in a slow, cold hydrological cycle that perfectly mirrors the water cycle on our own warm, wet world. This is where the true horror and wonder of Titan emerges, the possibility of a second Genesis. Could life exist in such a frigid, chemically alien environment? Our definition of life is profoundly Earth-centric, built around the necessity of liquid water. But Titan forces us to broaden that view. Scientists speculate that a completely different form of biology could have arisen in its methane lakes, a life that uses liquid methane as its solvent instead of water. On Earth, life is based on chemistry involving carbon and water. On Titan, life could be based on carbon and methane. Cell membranes, which on Earth are made of lipids that form bilayers in water, could on Titan be composed of acrylonitrile, a molecule already detected in Titan's atmosphere, which can form stable structures called azotosomes in liquid methane. These hypothetical life forms would breathe hydrogen instead of oxygen and consume acetylene or ethane for energy. Their metabolisms would be incredibly slow, operating at a pace dictated by the deep cold, with life cycles that could span millennia. The very thought of such creatures is unsettling, as it challenges our most fundamental assumptions about what it means to be alive. They would not be monsters in the traditional sense, but their existence would prove that life is not a singular, precious flame, but a cosmic phenomenon that can ignite in the most hostile and unexpected of places. If life can flourish in the freezing methane shadows of Titan, then the universe is not just habitable, it is absolutely saturated with the potential for biology, most of it so alien we might not even recognize it as life at all. The faint, uniform glow of the cosmic microwave background is the oldest light in the universe, a baby picture of the cosmos from its first moments. This afterglow of the Big Bang should be a nearly perfect tapestry, with only tiny, random variations in temperature. But as our telescopes mapped it with exquisite precision, they found deep and unsettling wrinkles in this primordial fabric. The universe's first portrait is marred by strange, giant features that defy our standard cosmic story. The largest of these anomalies is a mysterious alignment astronomers have grimly nicknamed the axis of evil. It is not a physical structure, but a bizarre correlation in the orientation of the temperature fluctuations across the sky. These hot and cold spots, the seeds of all future galaxies, appear to be aligned along a particular plane, a preferred direction in the cosmos that should not exist. According to our foundational cosmological principle, the universe should be isotropic, meaning it looks the same in every direction with no special place or axis. The axis of evil points a finger directly at that core principle, suggesting a fundamental directionality to reality that we cannot explain. It is as if you walked into a room that was supposed to be perfectly round and found all the furniture pointing toward one specific wall. How could the infant universe, in its first fiery moments, have possessed such a coordinated, large-scale structure? One radical theory proposes that this axis is a cosmic bruise, a scar left from a collision with another universe in the vast multiverse. Just before our own Big Bang, the theory suggests, our nascent cosmos may have been grazed by a neighboring reality, an impact that sent a directional shockwave through the very fabric of space-time, imprinting this eerie alignment onto the cosmic microwave background at its birth. Another possibility is even more mind-bending, that the axis of evil is a fossil from a time before the Big Bang, a relic of an earlier cosmic cycle whose structure somehow bled through into our own. Then there is the cold spot, a vast, unusually cold region in the cosmic microwave background that stretches over 1 billion light-years. It is a colossal void in the ancient light, a place that is significantly cooler than our models predict. At first, astronomers thought it might simply be a giant supervoid, an immense emptiness in the distribution of galaxies that would cause the light passing through it to lose energy. Yet detailed surveys have found no such void large enough to account for the profound cold. This leaves us with a chilling gap in our understanding. What could cause such a massive cold imprint on the universe's first light? One of the most speculative yet terrifying explanations is that the cold spot is the point of contact with another universe. In the multiverse scenario, our universe might be one bubble in a vast, frothing cosmic foam, where other bubble universes are constantly inflating into existence. The cold spot could be the shadow of a neighboring bubble that briefly brushed against our own during its earliest expansion. The energy of that collision would have left a distinct cold signature on our cosmic microwave background, a permanent scar from a reality we can never otherwise perceive. Of course, the most conservative explanation is that these are simply statistical flukes, the universe's equivalent of rolling a die and getting the same number a dozen times in a row. They are anomalies that exist at the very edge of our data's significance, and future observations might smooth them away. But if they are real, they represent a crack in the foundation of modern cosmology. They hint that our universe is not the perfectly random, isotropic cosmos we thought it was, but that it may have an architecture and a history far stranger than we ever conceived, written in the faint, cold whispers of its own creation. Even the ancient light of creation holds anomalies, but some cosmic objects shine with a ferocity that defies all reason. Quasars are the most violently energetic objects in the known universe, the brilliant, screaming hearts of distant galaxies gone mad. At the core of every quasar lies a supermassive black hole, but not a quiet, dormant one like Sagittarius, a star at our galaxy's center. This is a black hole in a state of frenzied consumption, a gravitational monster actively feeding on an orbiting disk of gas and dust known as an accretion disk. As this immense whirlpool of matter spirals inward at near light speeds, it is compressed and heated to millions of degrees, glowing with such intense friction that it converts matter into pure energy with an efficiency far beyond nuclear fusion. The result is a beacon of light so powerful it can outshine every single star in its host galaxy combined, visible clear across the observable universe. A single quasar can be thousands of times more luminous than our entire Milky Way, all emanating from a region not much larger than our solar system. This is the raw, unbridled power of gravity and friction on a cosmic scale. For Earth, a relatively nearby quasar turning its gaze toward us would be an unsurvivable event. The primary threat would not be gravity but radiation. The quasar would erupt in our sky, a new star of impossible brilliance, but its true danger would be invisible. It would bombard our solar system with a continuous torrent of X-rays and gamma rays, a lethal flood that would shred our planet's ozone layer in a matter of days. The sky would then become a killing field as unfiltered ultraviolet radiation from our own sun scoured the surface. The very air would become toxic, with the high-energy radiation transforming nitrogen and oxygen molecules into nitrogen oxides, effectively creating a global smog of acid rain. Photosynthesis would halt, collapsing the base of the food web and triggering a mass extinction that would make the dinosaur-killing asteroid impact look like a minor event. The terrifying reality is that this is not a permanent state for most galaxies. Our own Milky Way likely went through a quasar phase in its violent youth, a brief, brilliant, and sterilizing epoch before its central black hole consumed all the readily available fuel and fell quiet. We now live in the peaceful aftermath, but the universe is filled with these sleeping dragons. A sudden influx of gas, perhaps from a galactic merger or a disrupted gas cloud falling into the core, could theoretically reawaken the beast at our galaxy's heart. The quasar menace is a reminder that the brilliant lights we see in the distant cosmos are not just beautiful. They are the warning flares of galactic-scale infernos, capable of rendering entire swaths of the universe forever barren. The brilliant violence of quasars makes the silent, stealthy passage of our first interstellar visitor all the more unnerving. In October 2017, astronomers in Hawaii spotted a strange object speeding away from the sun. It was named Oumuamua, a Hawaiian word for a messenger from the distant past. This was not a normal comet or asteroid from our own solar system. Its trajectory and incredible speed revealed it as the first known object to visit us from the void between stars. The initial data was baffling. It had no visible coma, the cloud of gas and dust that typically surrounds a comet. This suggested it was a dry, rocky asteroid. Yet its shape defied all expectations. Based on its dramatic changes in brightness as it tumbled, scientists deduced it was highly elongated, shaped like a cigar or a pancake, with dimensions estimated at up to 800 meters long and only 80 wide. Nothing we have ever seen in our solar system looks like this. The strangeness only deepened when astronomers analyzed its path. As Oumuamua sped away from the sun, it exhibited a slight but undeniable non-gravitational acceleration. It was moving just a tiny bit faster than the sun's gravity alone could account for. This is a common trait for comets, as outgassing material acts like a natural rocket engine. But Oumuamua showed no signs of such outgassing. No gas, no dust, no tail. It was accelerating for no apparent reason, as if pushed by an unseen hand. This combination of oddities, its strange shape, its lack of a coma, and its mysterious acceleration, ignited a firestorm of scientific debate. The more conservative explanations struggled to fit all the facts. Could it be a fractal-like aggregate of dust, a cosmic dust bunny, or a shard of a planet torn apart by a rogue star's gravity? These are plausible, but they feel like a stretch. The most tantalizing and controversial theory came from Harvard astronomer Avi Loeb, who suggested we must at least consider an artificial origin. He proposed that Oumuamua could be a piece of alien technology, specifically a light sail. A light sail is a proposed form of spacecraft propulsion that uses the gentle but constant pressure of sunlight to accelerate through space, much like a sailboat uses wind. A thin, wide object, perhaps discarded or derelict, would perfectly match Oumuamua's observed properties. Its unusual shape would be ideal for sailing. Its lack of outgassing would be explained because it is not a comet but a constructed object, and its non-gravitational acceleration could be the result of solar radiation pressure pushing on the thin, lightweight sail. This is not proof, but a provocative hypothesis born from the data's stubborn refusal to conform. The true terror of Oumuamua is not that it was an alien probe, but that we will never know for sure. It is already gone, speeding back into the interstellar darkness from whence it came, taking its secrets with it. It was a fleeting glimpse, a single data point that reminds us the cosmos is filled with objects and phenomena we have not even begun to categorize. The universe may not only be stranger than we imagine, but stranger than we can imagine, and it is sending its messengers right through our neighborhood. Phantom energy is dark energy's malevolent twin, a hypothetical substance with such ferocious repulsive power that it could tear our universe to pieces not in trillions of years, but in a cosmic blink. While dark energy accelerates the expansion of space, phantom energy would supercharge it. its push growing stronger and stronger over time until it becomes infinite. This runaway force would lead directly to the most violent end of universe scenario imaginable, the Big Rip. Imagine the expansion of space not as a gentle, constant stretching, but as an ever-tightening noose. In this terrifying model, the very cosmological horizon, the farthest distance from which we could ever hope to receive light, would begin to shrink. Distant galaxies would not just fade from view as they crossed this horizon. They would be violently torn away from us as the space between us expands faster than light can travel. We would witness the observable universe collapsing in on itself, our cosmic neighborhood growing smaller and more isolated by the day. First, our galaxy cluster would be ripped apart, our neighboring galaxies flung into an unreachable void. Then the phantom force would target our own Milky Way. The gravitational bonds holding our galaxy together would be the next to fail. Stars would be plucked from their orbits and hurled into the expanding darkness, each one becoming a lonely, drifting ember. Our solar system would be next. The sun's gravity would be utterly overwhelmed. Earth would be ripped from its life-giving orbit, cast adrift into the freezing, airless void. But the horror would not stop at separating planets. As the phantom energy intensified, its push would overcome the force of gravity holding our planet together. Earth itself would explode, its continents, mountains, and oceans pulled apart in a final, catastrophic rupture. And in the last fleeting moments, the force would exceed the very nuclear bonds holding your body together. Every atom in the universe would be violently shredded into a diffuse mist of fundamental particles, forever isolated from every other particle. This is the ultimate dissolution, a reality where nothing can ever interact again, leaving behind a cold, empty, and silent cosmos. The timescale for this apocalypse is what makes phantom energy so unnerving. Instead of the distant trillions of years projected for a standard Big Rip, a universe dominated by phantom energy could meet its end in as little as 22 billion years, a mere heartbeat in cosmic time. This is not a far future abstraction, but a potential countdown that is already underway, a silent, accelerating deception hiding within the vacuum of space itself. The silent drift of interstellar messengers pales before the focused fury of a magnetar. These are neutron stars taken to an even more terrifying extreme, stellar corpses that possess the most powerful magnetic fields in the entire universe. A magnetar's magnetic pull is trillions of times more intense than Earth's, a force so concentrated it warps reality itself in its immediate vicinity. Within a distance of just 600 miles from the star, the magnetic field becomes strong enough to literally tear matter apart. It can strip electrons from atoms and reshape molecules into long, needle-like chains, a process that utterly annihilates the chemistry of life as we know it. These fields are not static, they are under immense strain, constantly twisting and stressing the magnetar's solid, crystalline crust. This tension builds over centuries until the crust can no longer contain it. The star's surface then fractures in a cosmic convulsion known as a starquake. Picture the most powerful earthquake imaginable, then multiply its energy by a factor of billions. A single starquake, lasting barely a tenth of a second, can unleash more energy than our sun will radiate over the next 100,000 years. This energy does not just vanish. It is channeled by the magnetar's colossal magnetic field into a focused blast of radiation, a gamma-ray and X-ray flash of almost incomprehensible power. Now, imagine such an event occurring not in a distant galaxy, but within our own cosmic backyard, just a few light years from Earth. The first sign would be a brilliant, momentary flash in the gamma-ray sky, invisible to our eyes but blinding to our satellites. An instant later, the radiation wave would arrive. It would be a silent, invisible tsunami of high-energy particles slamming into our planet's atmosphere. The upper layers of our air would be violently ionized, creating a chemical smog of nitrogen oxides that would rapidly eat away at the protective ozone layer. Within days, our shield against the sun's ultraviolet radiation would be in tatters. The surface of the Earth would be bathed in a sterilizing glow, crippling the phytoplankton in the oceans that produce most of our oxygen and breaking the food chain at its most fundamental level. The long-term consequences would be a slow, planetary-wide extinction event, a biological catastrophe triggered by a single, distant stellar heartbeat. Thankfully, the nearest known magnetar is thousands of light-years away, a safe distance from our fragile world. But their existence serves as a stark reminder that the cosmos is filled with natural particle accelerators of unimaginable violence, capable of ending life across interstellar distances with a single, catastrophic twitch. The crushing ice of a distant moon hides a secret ocean, far beneath the frozen, fractured crusts of worlds like Jupiter's Europa and Saturn's Enceladus. Vast, global seas slosh in perpetual darkness. These are not the sun-drenched waters of Earth, but alien abysses sealed under miles of ice, with pressures thousands of times greater than our deepest trenches and temperatures hovering just above freezing. Their existence is a marvel of planetary science, maintained not by the sun's warmth, but by the relentless gravitational kneading from their giant parent planets. This tidal friction generates immense heat from within, preventing these hidden oceans from freezing solid and creating conditions that could, just maybe, support life. We have seen the evidence ourselves. Geysers of water vapor and ice crystals erupt from the south pole of Enceladus, spewing into space from a subsurface sea, while Europa's young, cracked ice shell suggests a warm, churning ocean below. The possibility that we are not alone in the universe suddenly becomes not a question of distant stars, but of our own celestial backyard. These dark waters could be the largest reservoirs of liquid water in the entire solar system. The hope for finding life there is profound, but it comes with a chilling undercurrent. What kind of life could evolve in such absolute isolation, in a world without light, without seasons, without any connection to the surface? On Earth, life is built on photosynthesis, harvesting energy from the sun. Down there, in the eternal night, any ecosystem would have to be founded on chemosynthesis, drawing energy from chemical reactions between the water and the rocky seabed. Around hydrothermal vents on our own ocean floor, entire communities of bizarre creatures thrive on this chemical energy-blind shrimp, giant tube worms, and strange bacteria that consume sulfur and methane. The life in Europa's ocean could be similar, but it has had billions of years to evolve in a completely sealed environment. It would be fundamentally alien, its biochemistry potentially taking paths we cannot predict. The horror is not that we might find simple bacteria, but that we might find something more. A complex creature that has never known a predator, never experienced competition, evolving in the silent, pressurized dark for eons. Its senses would not be sight, but the perception of subtle shifts in pressure, in electrical fields, or in the chemistry of the water. It might be a slow, gentle filter feeder, or it could be something far more formidable, a predator shaped by a world of endless black and crushing force. The true terror lies in the utter foreignness of such an organism. Its very biology, its motivations, its place in that ecosystem would be so removed from our understanding that contact would be incomprehensible. We would be visitors from a bright, gaseous world, intruding into a realm where our existence is as alien to its inhabitants as theirs is to us. The ice shell is not just a barrier of rock and ice. It is a barrier between two entirely separate biologies, and breaching it could be an act of profound and irreversible contamination. Even the most violent stellar engines will one day fall silent. The final act of our universe is not a fiery collapse or a dramatic rip, but a slow, chilling fade into absolute stillness. This is the heat death, the ultimate state of maximum entropy. Imagine a clock that is slowly, irrevocably winding down. Every star is a wound spring, releasing its stored energy as light and heat. Every galaxy, every black hole, every flicker of radiation is a temporary pocket of order in a cosmos that is relentlessly moving toward disorder. Over trillions upon trillions of years, the last stars will exhaust their nuclear fuel and burn out, leaving behind cold, dark cinders. The galaxies, now devoid of new starlight, will drift apart into an ever-expanding blackness, their structures dissolving. Even the supermassive black holes, the last bastions of concentrated gravity, are not eternal. Through a quantum process known as Hawking radiation, they will evaporate over almost unimaginable timescales, releasing their final whispers of energy into the void. Eventually, the universe will achieve a state of perfect equilibrium. The temperature will approach absolute zero, a cold so profound that all molecular motion ceases. With no temperature differences, no hot spots or cold spots, no energy gradients whatsoever, the universe will be a uniform, thin soup of subatomic particles spread infinitely thin. In this final state, no work can be done, no engine can run, no thought can form, no life can possibly exist. It is a silence more complete than any we can conceive, a darkness without end. This is not an explosion, but an exhalation that never ends. All the drama of cosmic history, the birth of stars, the collision of galaxies, the rise and fall of civilizations, will leave no trace. It is the most accepted scientific forecast for our cosmos's end, a quiet, eternal, and profoundly lonely conclusion to everything. From the silent, predatory pull of the Great Attractor to the final, frozen whisper of heat death, we have journeyed through 25 cosmic terrors that reveal the universe's darkest face. These are not monsters from fiction, but real, existential threats born from the fundamental laws of physics. The cosmos is a place of breathtaking beauty, but it is also a realm of immense and utterly indifferent power. It does not harbor malice, for it does not need to. Its simple, natural processes, the collapse of a star, the decay of a vacuum, the relentless push of dark energy, hold the potential to erase us, our world, and even reality itself without a second thought. The profound silence of space, the ruins of cannibalized galaxies, and the ticking time bombs of zombie stars all point to a single, humbling truth. Our existence is a fragile, fleeting anomaly in a universe that is, for the most part, spectacularly hostile to life as we know it. The cosmos is full of wonders and terrors beyond our imagination. What do you think is the most terrifying concept we discussed? Let us know in the comments below, and don't forget to subscribe for more journeys into the unknown.